Okay, there we go. All right, so that's done. I'm posting the link one last time and let's get started and let's see how this goes. So this is a little bit of an experiment, okay? But what I want to do here is I want to take some 5-10 minutes to just get us warmed up and just make sure that we are all on the same page with respect to the key concepts that we have covered so far. And if not, then I can just fill in some of the gaps, right? So we'll do this in the form of a quiz, all right? And so okay, waiting for players to join. A lot of sound effects, but okay, there we go. We got all our players. Wonderful. Let's start the quiz and see what happens. Questions coming up. And there we go. I think you have 25 seconds to answer this question. If no arrangement is used for layout, components behave as follows. So pick the one that you think is the most accurate. Almost done. Time's up. Okay. Were you able to answer the question? I didn't see any responses. Chat box. I forgot to submit. Okay, no problem. Okay, so the answer to this one is that unless we use a layout, components will just stack up below each other, right? So each new component will just go and position itself below the previous one, all right? So if you picked a name and your avatar, technically, oh, there we go. Okay. All right. Oh, and you can pick a name which is not your real name, so we can have some secrecy, but we are all at the same level right now, okay? Usually that's what we do. When we do these quizzes, we pick a fake name and then, yeah, whoever wins, they announce themselves. Okay, let's do the next question. Let's hope this goes better. So question number 2, 5, 4, 3, 2, 1, 0. Which of the following correctly describes the use of arrangements for layouts? So pick the one that you think is the most accurate. Pick, 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 pick. Time's up. No responses. Oh, we got 3 responses. Awesome. Awesome. So three of you got it. All 3 of you who responded got it right. So yes, we use arrangements to force components to sit horizontally next to each other or vertically on top of each other. And arrangements themselves can be nested. So you can put 2 vertical arrangements inside a horizontal arrangement and so on. Excellent. Good. At least it's working somewhat, huh? We got some responses. Good. Wonderful. All of you got it. Okay. Question number 3 coming up. Which of the following components from the control drawer does not require a test condition? So an if-then statement, a for loop, or a while loop. And we may not have used all of these, but do your best. So a test condition is a condition that evaluates to a true or a false, right? So pick, pick, pick. Time's up, almost there. Okay, so it does not require a test condition, right? So an if-then statement is basically a way to make decisions in our program, right? And so what is a decision made on the basis of? So it's made on the basis of a test condition, which evaluates to a true or a false. So if it's true, it will execute one way. If it's false, it will execute another way, right? So the for loop does not require test conditions because it will just loop through a series of numbers like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it will just loop over a series of numbers. So there's no test condition. Right. Okay, good job. Today is kind of just a test run of this, okay? So we'll do better next time. Which of the following sensors does not measure motion or location? GPS, accelerometer, gyroscope, light sensor. This should be easy, Maybe not. Time's up. All right, light sensor, yeah. Yes, gyroscope measures motion, right? The accelerometer measures linear motion or change in linear momentum. And the gyroscope measures change in rotational angular momentum, right? So both of them do measure motion, just differently. All right, good job. So who do we have on the top of the video? Belinda, all right. Last question. Which sensor to use for moving an animated character by tilting the phone? So which sensor will register tilt? We haven't worked with animated characters yet, but kind of the question is more about which sensor is best for measuring tilt. Okay, well, one of you got it, accelerometer. Okay, so this is a bit counterintuitive, right? We just said gyroscope is for angular momentum or change in angular momentum. So it seems to imply that when we tilt the phone, we would use the gyroscope. Gyroscopes are a little temperamental and a little difficult to use, although that's not to say we shouldn't use them. But the accelerometer turns out to be much more convenient to use for even measuring the tilt of the phone. And we'll see that when we build our app number 3, which is called Pong. So today we are going to start by building an animated game and how to animate characters. But as we come to our app number 3, we'll get more knowledge about using the tilting motion of the phone to move a character on the phone screen. So a little bit of a trick question, yeah? The gyroscope seems to be the natural choice, but the accelerometer is the correct answer. So good job. And awesome. Good job, Belinda. Nicely done. Do you want to explain the reasoning behind the last question? Like why use the accelerometer and not the gyroscope for measuring tilt? Feel free to unmute yourself and share with others. No? Okay, guess not. All right. So let me stop this. And please put in the chat box how you felt about the quiz. Today was just a dry run. So if you like it, then I'll purchase a subscription so we can do it. Oh, you got that one wrong. Okay, I see. So we can do that again. So who got the last one right? Okay. Okay. If you feel like explaining the accelerometer or the gyroscope for the last question, feel free to unmute yourself and share with the others. Okay. But yeah, if you like the quiz, thanks, Vivian. Vivian says she loves the quiz. So good. So there is a subscription cost. So I'll pay it. But before I pay it, I wanted to make sure that at least some of you like it. Yeah, Denise, Mary Beth. Yeah, so I'm using the free version. So sorry you could not join this one. So I think the free version allows only 7 participants, and we already got started just after 4. So sorry you weren't able to join in. But yeah, so you will be able to join in the next time we do this, okay? Okay, so it's about 15 minutes past 4 and there's a lot to cover today. So I'll get started. What we are going to do today is build an app, our first animated game, yay! And let me first show you what that looks like before we get into the code. What happened to my, let me close stuff I don't need. All right, there we go. And there is no emulator. Give me just a moment to get the emulator started. Emulator's coming up. I'm unable to join as well. Yeah, Anirudh, we'll sort it out. We'll sort it out, okay? Don't worry. Today was just a test to see how well the quiz works. So thanks for the feedback. All right. I want to show you what we're going to build before we start building it. And the emulator is taking a little bit of time. Okay. So this is a game called Mole Mash. And do you see the animated character? It's a little mole, right? And it's a simple game. I squash the mole to score points. So if you look at the little text label below where it says score, yeah. So right now I have slowed the mole down, so it's moving kind of slow, but we can speed it up so it becomes a little more challenging. And when I squash the mole with, right now I'm clicking on it with the mouse, it makes that squeaking sound. I hope you can hear that. And I score points, yeah. And then I can reset it and score goes back to 0. And yes, when I click on the mole, that's how I earn points. So it's a very simple game. And what we will do is, in the process of building this game, we'll build this game from scratch. We will learn some key concepts underlying animation. Chiefly, how do we use a canvas and sprite? So these are components that App Inventor provides. And canvas and sprite are used for animation for any game that we build in the world of computers today. Yeah. So that's the game. And as we do this today, I'm going to go really slow. I'm going to pace myself and feel absolutely free to unmute yourself and ask a question if there's something you're not following. Okay. So don't be afraid to unmute yourself and ask a question. And what I'm going to do right now is, this is the Mole Mash starter app. Some of you had questions about how to import that file. When you download it, it might look like a zip archive with multiple files, but it's actually just one file all bundled together. And what you do is you go to the projects menu and you go to import project from a repository, and then you point it to your AIA file, and that's how you can load the AIA file into your App Inventor. Okay. So right now I'm going to delete all these and start from scratch. Everything will start from a blank slate. All right, all my code should have disappeared. Delete this too. Into the trash can. To the trash can. That's it. I'm going to start with a blank slate and save the empty screen now. And when we build any kind of animation, we start by going to the drawing and animation drawer. And the first component we want to pick is a canvas. Okay. So I grabbed the canvas and I dropped it onto the screen. And I'm going to set its height and width to take up all the available real estate. So I'm going to height and width and choosing fill parent. So it's going to take up whatever is available. It doesn't look like it's doing that right now, but just be patient and you'll see that in a moment. And the drawing and animation drawer it doesn't have a whole lot, right? It has canvas, it has ball, and image sprite. So today, because we are starting out, we are going to pick image sprite and drag and drop it onto the canvas. I'm going to rename it to mole sprite. So just change the name of the component. And doesn't look like much yet, right? Because we haven't given it any properties. So go to canvas. In your starter app, you should have all the media files that we need in the media drawer. So I'm going to make the canvas look like a background that you would expect to find a mole in, right? A mole's habitat. So go to the background image property and pick, I believe it is molehole.png, okay? And now you see it looks a little more like what we saw at the beginning, right? So basically the canvas has these properties like background, height, width that we can use to define the look and feel of that. Let's also make our mole look like a mole. It doesn't have any image right now. So you just see a tiny rectangular box here, which is actually empty, right? So which property do you think I need to pick to make it look like a mole? Height, width, interval, picture. That looks like a reasonable guess, right? So we'll change the picture to mole.png, and there we go. So now we have our canvas and sprite. The next thing we're going to do is animate it. And what happens in this game is the mole is just jumping all over the canvas, right? And it jumps at a certain speed. So one key concept in any kind of animation is this concept of a clock and a timer. So the first thing let's do is let's go to the sensors drawer and grab a clock and drag and drop it to the screen. And because it's not a visible component, it's going to appear below the screen, right? And we're going to change its name again to, or we can leave it as clock 1. I also want to show the score. So I'll go to the user interface drawer and pick a text label and drag and drop it just below the canvas. And then I want a reset button. So I'm going to pick a button and going to drag and drop it. And again, the canvas, I'm going to just change the text label. I'm going to change its background color to cyan just to make it visible. I'm going to go to its text property and set it to score 0. It's just a text label, so it will just show whatever I put inside this box, okay? And then the button, I'm going to change its text. I've selected the button now. I'm going all the way down to its text property and just change it to reset. Leave it in capital so it's visible. In fact, I think I'll capitalize score as well. Also change the font of these text labels. So go to font size, maybe change it to 24, something bigger here. Reset button, likewise, change it to 24, keep everything consistent. Okay, so these are a little bigger. So we have all that we need. I think let's also pick a sound component. So we can make the mole squeak when the player touches it. So now we have everything we need, right? It just doesn't do anything. Okay. So let's go to the blocks and start filling out this coding canvas. The first thing we want to do is we want to make the mole just move all over the canvas. Okay. And for that, I'm going to use the clock and timer. And if I look at the mole, clicking on the mole right now, it has these attributes called X, Y, and Z, right? So there's a coordinate system here, which is your canvas is basically a rectangle, right? It's a piece of real estate in the shape of a rectangle. The origin 0, 0 is at this top left corner where I'm pointing, right? And then the X coordinate increases as I go from left to right, and the Y coordinate increases as I go from top to bottom. And our unit of measure The numbers that you see here, like x85, y15, these are pixels, right? So each individual pixel on the phone screen. So x is going to be positive numbers starting from 0 here, and the width of the canvas, which currently is the width of the screen, as I go from left to right. And the y coordinate, likewise, is going to start from 0 out here and going to increase as positive numbers from 0 all the way to the height of the canvas. All right, so when you go to canvas, you see properties, width and height, and we can use these in our code. So let's go back to blocks. And first, let's just write a procedure to give the mole an x and y coordinate, okay? So this is the first time that we are using a procedure. So I'm going to go real slow, click on the procedures drawer, and just grab the block that says procedure. And let's give it a new name, move mole. And it's going to do exactly what we named it as. It's going to move the mole to a random x and y location on the canvas. All right, so inside the procedure now, what do I care about? I care about the mole, and I care about the mole's location, and location is x and y, right? So I'm going to click on the mole sprite, and I'm going to find, we spoke about the get set methods, remember? So I'm going to find a block to set the x and y coordinates of the mole. So here's something that looks interesting, right? This is set the mole sprite x to something. I'm going to duplicate it. So I don't need to go to the mole sprite every time to pick these different get set blocks. I can make duplicates and then I can configure them by clicking on these drop-down boxes, right? I'm going to set the x to what? So I'm looking for a random number. And where do you think I'd find a random number? A good guess would be the math drawer, right? So let's go into the math drawer and pick a block that gives me a random integer. Okay, duplicate it and do the same for y. This is not going to do anything yet because we've just written a procedure, but we are not executing it. But what do I want the x value to be? Do I want it to be between 1 and 100? I actually want it to be between 0 and the width of the canvas. You following? And likewise, the y, I want it to be a number between 0 and the height of the canvas, right? So let's go back to block and let's change the 1 to 0 for both of these, okay? And this 100 is no use to me, right? So let me just get rid of that and instead use the height and width of the canvas. So where would I find these? Click on canvas. So there would be a get method for height. Here it is, get height. I'm just going to copy it and use it for the width as well. Actually, the x is the width, right? Here we go. So I can get rid of these numbers. Right. And so now we have written a procedure that when we call it is going to give the mole an x and a y coordinate, which is something between 0 and the width of the canvas for the x and 0 and the height of the canvas for the y. But to call the procedure, this is where I'm going to use a clock and a timer. And a clock and a timer is just like our alarm clock, right? So if we set a timer on a clock, if we set an alarm on a clock, then it's going to go off as per our setting. So I set my alarm at 5:30 in the morning, and at 5:30 in the morning, the alarm goes off. So this clock is just the same. It has only one event called the timer. It is the same as our clock in the physical world. And when I use the timer event, what I'm telling the clock is at every time interval, trigger an event, okay? So the time interval could be 10 seconds, 40 seconds, 50 seconds. It doesn't matter. It's up to me to define the time interval. And then every time that time interval is completed, it's going to fire off an event. And when that event fires off, the code that we put in this event handler will be executed, right? So it's just like any other event handler. We have an event, and then when the event is fired, the code in the callback the code that we put in the event handler is executed. The callback is executed. And now that we have a procedure to move the mole to a random location on the canvas, let's just take that procedure. You see in the procedures drawer, there's a new block which appeared. So this Lego brick call move mole is one that we just created, right? So procedures is a way to create our own Lego blocks for what we want to do. And now that I have this new Lego block, I'm going to put it there. And what should happen now is the mole should actually start moving all over the canvas. And do you see? It has already started doing that. Okay. And it goes off the canvas edge now and then. We'll fix that in a moment. But you see the mole, the most important thing is the mole is moving and we've successfully animated our character. Now, what is the frequency at which it is moving? We didn't specify any frequency here in the timer. We said when the timer goes off, move the mole, and then it calls the procedure and gives it a new X and Y, right? If we go to the designer and we go to the clock, we see it has a default timer interval, right? So even though we didn't explicitly specify one, there was a default value already. And it's in milliseconds. So 1 second is 1000 milliseconds. So it is moving to a new location every second. So I'm going to make it 500, which is half a second. All right, I'm going to change that property. And now if I go back to the emulator, you'll see the mole is moving much faster. Yeah. And it would be harder to kind of stab it with the finger on the actual phone or click on it with the mouse. Yeah. So it's giving me a run for the money. All right. So I'm going to go back to 1000, go back to 1000, 1 second. So it's a little more manageable. All right. Any questions so far? Following along? Okay. Now you'll notice that the mole goes off the edge sometimes, right? And the reason is every component in App Inventor has a rectangle around it. You may not see it, but that bounding box is always there. And in terms of the coordinate system, the top left corner of that bounding box is always 0. So imagine I were to draw a rectangle around this mole, right? It is not a rectangle by itself, but App Inventor will put that rectangle around it. And the top left corner of the rectangle is the origin as far as the mole is concerned. It's the same for the canvas, right? The top left corner of the canvas is origin or 0, 0. So what happens is when we set the X and Y of the mole, if we set the X to 0, then it's going to be somewhere on the left edge, right? But if we set the X to the canvas width, since the origin is the top left corner of the box around a mole, the mole can actually slide off the canvas. Okay, so imagine that rectangle around a mole, that rectangle is sitting right next to the rectangle representing the canvas, yeah? But essentially the mole has, the image has gone off the canvas, even though the mole is still on the canvas. It's just on the very edge. So we're going to modify what we have done just a little bit. And what we're going to do is instead of the canvas width, we're going to pull back the canvas perimeter on the right side and on the bottom by the width of the mole. We're going to pull the right edge to the left by the width of the mole, and we're going to pull the bottom edge towards the top by the height of the mole. It's a simple subtraction, right? So that way the mole image never goes off the canvas. And so we go to the math drawer, grab the subtraction. So it's just a small change we are making. Instead of the canvas width, we are saying 0 up to canvas width minus the width of the mole. And where would I find the width of the mole? Click on the mole and use the get method for the mole's width. I'm going to duplicate this whole block to save myself a little bit of coding. And I'm going to change the properties to height. Okay. And yeah. So where I was going 0 to canvas width, now I'm going 0 to canvas width minus the width of the mole. And 0 to canvas height, I'm going 0 to canvas height minus height of the mole. Okay. So by now, the mole should be always visible, not going off the edge of the canvas. Okay. Although in the emulator, sometimes you may see certain problems, but yeah, I think it's doing reasonably well so far. Okay, the mole is now moving. Stop me if you have any questions, but there is no action to this game. And what we really want is when we touch the mole to score points. So we are going to implement that now. And we will start with the mole sprite, which has an event called touched, right? So far in the app that we built, the soundboard app, we had a button and we used what event of the button? We used the click event. So this is just like clicking a button, except we are clicking a sprite. So just like the button's click event, a sprite has a touched event. And notice that a sprite has a diverse number of events, right? Other than just touched, it can collide with another sprite. It can reach the edge of the canvas. You can resolve the touch to touch up, touch down. We'll use these in subsequent apps that we built, right? So for now, we just need the touched event. So when we click on the mole or when we touch it with the finger on the actual phone, then whatever code we put here in the callback will be executed. Now, what do we want to do here? We want to do three things. First, we want to keep track of a score. So there's a score label here. So we want to count the score. Every time the mole is touched, we want to go from 0 to 1, 1 to 2, 2 to 3. So we have to track the score and we have to show it. Number two, we would also like to play a sound. We would like the mole to squeak when it is touched. So that's what we will use the sound component for. And number three, we would like to pause the game for a second. We would like to suspend all the animation for a second or two. It's a way of giving feedback to the player that an event occurred. You successfully touched the mole, right? So we'll do these three things and we'll code them one by one. So the first thing we'll do is we'll keep track of the score. And how to do that? So if you remember, we just started using variables in the last app that we built. And when we click on the variables, we see our old friend global variable. And a variable is just a way of giving an app some memory. If you remember, it's like an app the app now has a spreadsheet where it can save data using labels like score or whatever we provide here. So I'm going to call this piece of information score. And this piece of information is what? It is a number that starts with 0, right? And anytime in our code, we can query to get the value of the score, and we can also change the value of the score. So we have a get and a set method. The get method will tell us what the score is. The set method will change it to a new value. So when the mole sprite is touched, the score starts out with 0. What we want to do is to set the score to the current score plus 1. So whatever the current score is, I'm going to need the get method to query it. And then I'm going to need a little bit of math to add 1 to this. So I grab the addition block from the math drawer. I'm adding 1, which is a constant, to the current score. Right? Now, every time the mole is touched, there is a new score, which is the old score updated by 1. And this is part of the app's memory, so it remembers that. Yeah. But I'm not showing the score yet, so let's fix that. To show the score, what do we need? We need the label. And by now, I think you can figure this out. We need a set method to change the label's property. What property do we want to change? The height? No. The text, right? Which should show the new score. To query the score, which I've just changed, I'm again going to use the get method. And this should work. Okay, I clicked on the mouse and the score increased to 1. And notice, if I can do this again, 2, 3, yeah. Notice that we wanted a label that says score, number. So let's fix that. I'm showing just the raw score here. So if you go to the text drawer, it has a number of blocks for text manipulation. You can query for the length of a block of text. You can check whether it's empty. You can compare strings. So blocks of text in computer science are called strings. They're essentially just blocks of text. We can compare them. We can create blocks of text. We can modify them. We can compare them. We can do a whole lot with text, which is what all these blocks are for. Today, we are just going to use this block join to combine text together. And what do I want to combine? I want text that says score, space, and then the score. Okay, what this is going to do is it's going to take this constant score, space, and then show the current score right next to it. Okay. The nice thing about text is when you give a text block numbers, even though numbers are strictly speaking not text, it will auto convert the number to text, and vice versa also for the most part. So that should now give me, when I click on the mole, nothing has happened yet. Yes, now you see the code that I just implemented is now showing me score and then the number. And from now on, whenever I click on the mole, that's going to be its behavior. Any questions so far? So we've done one of 3 things we wanted to do when we actually touch the mole. Okay. So there's some key concepts that we have learned already. The most important one is really how do we use a timer to animate. And when you go to a clock, the timer is an event that is belongs to the clock component. The clock component doesn't have a whole lot of properties. It does have a ton of methods. You see here, timer enabled, timer always fires, timer interval. Most of the times we will work with timer enabled and timer interval in animation. And one fact to keep in mind is that a timer can be enabled or disabled. So if I uncheck this box, then the mole should stop moving. Okay, so you see the mole, its action is suspended. And I check this box again, it will start moving again. So when we control animation, there are many ways to do that. We are just looking at some very beginning principles. We'll usually associate a clock with an animated character, and these timer enabled and timer interval are the properties that we'll be working with most frequently. Can do a lot more, you know, when we work with animated characters like a spaceship that fires bullets, that moves from the left to right, from top to bottom, that collides with other spaceships or aliens or what have you. When you have games like Mario Run or Flappy Bird, you can do all of that, right? You're still going to use a timer, a clock and a timer, okay, with your animated characters. So this concept is really, really important. So practice it. And if you have any questions, just make sure to unmute and let me know. Yeah, so now that we've gotten our mole jumping around, we are also increasing the score. Let's expand on this callback to play a sound when the mole is touched. All right. And we've done this before. We'll do it again. We are going to use the sound component. We are going to set the sound source, because in this app, I'm going to use one sound component to play multiple sound recordings. And so what is the sound we wanted to play? This mole squashed.mp3 that I've already prepared for you. So go to text and type in exactly mole squashed.mp3. Now this has to be typed in, it is case sensitive and it needs to be typed in exactly as it appears here, okay? And so we've set the source. So now let's play the sound. And let's also vibrate the phone. When you click on the sound component, you see it has a vibrate method, a block for vibrating the phone. So if the sound is annoying, then we have this additional way to alert the user that you did actually touch the mole, right? And this will not work in the emulator. There's no way to vibrate the phone in the emulator, right? But it will work on the actual Android phone. We need to tell it for how long to vibrate. So usually this is like 500 milliseconds. It's a short duration of time. And now, in addition to incrementing the score, we'll also hear a sound. Let me turn up the volume all the way for now. Okay, so my mole now makes that squeaking sound every time I squash it with my finger or click on it with the mouse. Okay. All okay so far? You guys seem to be on the same page, so that's good. And the last thing, so notice when I click on the mouse, it keeps moving at the same pace as before. So what I would like to do is actually suspend all action for a while when the player touches the mole. And for that, I'm going to write a sleep procedure. So today we are learning not only about clock and timer, we are also learning and getting practice with procedures. This is a very important part of coding. And as we did before, I go to the procedures drawer and grab the block for an empty procedure. I'm going to call it sleep, or I could call it wait. I prefer to call it sleep. And what I want this procedure to do is when we call it, stop everything and just sleep for n milliseconds. So I need to tell it how long to sleep, right? So if you see this little blue box, I click on that and it says input X. So I'm just going to allow the sleep procedure to accept an input. I'm going to call that input N. All right. So the move mole procedure that we coded before, it doesn't have any parameters. It just moves the mole to a new random location each time. The sleep procedure is a little more advanced, right? It has a parameter which we can use to configure its behavior, which is tell it how long to sleep. And how to actually implement the sleep. So the logic of this is going to be as follows. Whatever the time is right now, I look at my clock and say, okay, it's 4:15 or 4:30. I'm going to add n milliseconds to the current time. And then I'm going to wait that long. So first of all, let's just work with adding these n milliseconds to the current time. So when we call the procedure, we'll go back to our old friend variables. And this time we will use a local variable. All right. So local variable is visible only inside the procedure. Nowhere else in the code does this mean anything. Does this variable ring any bells? The global variable is accessible anywhere in our program. That's the difference, okay? And what I'm going to call this local variable, so it's like local memory, is target. So that's the target until which we will wait, until when we will wait, yeah? And the target is based on the current time. How do I get the current time? So click on clock and you see a ton of methods related to working with time. There are methods to query the current time, to add, subtract seconds, minutes, hours, days, weeks, months, years to time, to compute the time interval between two dates, to format dates for display in many different ways. Yeah. So there is a ton of methods in there. So in computer programming, clocks are very important. You can guess that, right? And that's why the clock component is rich and has so many methods. And what we want today is this one called system time. There's also one called now, which tells the current time. but it reports the time in a slightly different way. So we're going to just use system time. So what system time is the time that your phone is telling you is the current time. Okay. And it's time in hours, minutes, and seconds. And what we're going to do is we're going to do a little bit of math on the time, and we're going to add n milliseconds to the current time. So the nice thing is we can get n from the procedure and we can just add it to time, just like any other arithmetic we do with numbers. It's very convenient, right? And so when we do this now, we have a new target time. And until we reach the target time, we just want to wait. So I'm going to go back to the control drawer and grab a while loop. We have not used the while loop before, so this is the first time we are using it. Until now, from the control drawer, we just use the if then and if then else statement, right? And it also has a for loop and a while loop. And these are really all very foundational to programming, right? So what the while loop does is it has a test condition. And until the test condition is true, it will keep repeating whatever it is we tell it to do inside the code in this handler, in this block, right? So it will keep repeating what we tell it to repeat over and over and over until the test condition is false, and then it exits. What is our test condition? So again, we want to test that the current time is less than the target time. So I go to the math drawer and click the block for comparison. And I'm going to set it to less than equal to. Again, I go back to clock and pick the system time. What I'm checking for in this condition is that the system time, so while the loop is running, yes, it keeps running over and over and over. And every time it checks, what is the time now? What is the time now? What is the time now? And it compares that time now to our target time. And as long as the time now, the system time, which keeps changing, right, is less than the target time, it will do nothing. It'll do absolutely nothing. So I'm not even going to put any code inside this while loop. All right. But the moment the system time is greater than the target time, it stops. And that's why this procedure effectively sleeps for n milliseconds. Okay. So now that I have the procedure, all that remains is to go to the procedures block, to the procedures drawer. You see the sleep procedure has appeared here. So it's a new block that we just created. And I'm going to drag and drop it and add it to the long callback for the touched event handler. All right. Just one little thing remaining to do is to tell it how many seconds to actually sleep for. And 3000 means 3 seconds. Okay. So let's run with that and see what happens. Okay, there's the mole. We stabbed it. 1, 2, 3, and it started. Okay, let's try that one more time. 1, 2, 3. Score went up to 10 and it started moving again. Let's change it to something bigger. Let's say 6 seconds, right? Just to show you how a procedure works when we pass it a parameter. Again, it's running. Mole is jumping all over the place. I stab it, missed. Okay, gotcha. 6, 5, 4, 3, 2, 1. All right, so you see the sleep procedure is now working. And I'll just pause and take any questions. Type them in the chat box or feel free to unmute yourselves.
Hi, Sanjay, can you hear me?
Doing okay? Sorry, I missed what you said. I apologize. Can you say that again?
Hi, this is Denise. Can you hear me?
Yes, I can hear you. Yeah.
Okay, I'm wondering, is there a way to speed up the mole as
Yes.
the score gets higher?
Yeah, excellent point, right? So that's going to be your homework, right? And that's a great point, right? It's to keep it simple for demonstration purposes. We have made this a very simple game. What you would do to speed up the mole is, as your score goes up, you would probably write a procedure to calculate the new score. And in that procedure, you would not just compute a new score, you would also reset the timer interval and make it smaller and smaller and smaller. Yeah. So you would decrement it by some constant, say 50. And so every time the mole is touched, here's the code that we are using to increase the score. Let's take out all the sound components, right? And let's put them back. You'd put this into a procedure, okay? And you would add one more line here to set the timer interval. Where do I find the timer interval? It's a property of the clock. So set timer interval. And what I would do is I would also need to get the current setting and make it shorter, right? By subtraction. So I'm going to the math drawer. And the shorter the time interval, the faster the mole will jump around, right? Okay. And so that would make the mole speed up every time I pressed on it. Now I can write another procedure for this, or I can just leave it here. In general, as our callback grows in size, then we take bits of code out and put them into procedures. It's just a cleaner way of writing codes, but this should work too in answer to your question.
Thank
And
you. Yeah, that's nice. Thanks.
yeah. Oh, it's pausing for too long. So let me make this just, yeah, I don't know if you'll be able to perceive the effect with the 50, but yeah, this should effectively, now the mole will speed up every time I touch it. Okay.
Thank you. I
Yeah.
appreciate that.
All right. Great. Now, one thing you'll see is when I click on the mole, it pauses. That's great. But let me first try to hit it. Chewing gum and walking. Yeah. See, what I'm doing is, while it's paused, I can still hit it repeatedly. Yeah. Let me make the pause a little more dramatic. Make it 3 seconds. Reset it. Oh, the reset button doesn't work yet, right? So when I click on the mole, oh, it speeded up quite a bit. So it speeded up quite a bit because of what we just did, right? So let me reset it. Refresh companion screen. So you see, while it's pausing, it will continue to hit it over and over and over. Yeah. And that's not what we want. Okay. What we want is really all the activity to be suspended when I hit the mole. So it turns out that usually when you want to suspend the activity of an animated character, what you should really be doing is to disable its timer or disable the timer on the clock that is animating it. That's what I had shown you by clicking on this timer here. So we're going to put in that change. We're going to write another sleep procedure. Okay. Because I want to leave this one around. They will both do the same, but the second sleep procedure will stop me from actually touching the mole while we are paused, right? So while we are in this state of suspended animation, when the player touches the mole, nothing should happen. I should not be able to touch on the mole again and just touch and score more points, right? So that's what we are going to do. And I'm going to go to procedure and grab a block for a new procedure. We'll call it sleep for n milliseconds. So I need to give it a different name to distinguish it from the other procedure, right? Otherwise, functionally, they're going to do the same thing. They're going to stop the mole from jumping around when the player has touched the mole for a few seconds. And what we'll do here is actually use a timer to achieve the suspended animation effect. So one clock can have only one timer. So to do this, I'm going to need to grab another clock, clock 2. I can have as many clocks as I want in my code. And actually for this clock, I will disable the timer. We'll enable it only when we need it. All right. And the timer interval is what I'm going to use to suspend the animation. So I set it to 3000, but we can set it when we call the procedure sleep 4. Call it sleep 4. Yeah, sleep 4 is fine. It's a valid name. And the correct way to actually suspend animation is to disable the timer. Where do we find a timer? So the mole's timer is clock 1. Go there, scroll all the way to the bottom for the get set methods, and set the timer enabled. Okay, the timer enabled to false. So this has the same effect as checking or unchecking this timer enabled box. And as you saw earlier, when I uncheck this box, the mole stopped moving. What we are doing here, how is it different? We are doing the same action, but using a procedure to do that, right? So set the clock's timer enabled to false, and then kick off this timer, right? And when this timer fires its first event, we will then resume. So this procedure will put things into a state of suspended animation, and then the timer itself will resume operation the moment it fires off its first event. It's like when the alarm clock goes off on this timer, this clock 2 timer, we will resume animation. Okay. So what do we want to do? What we want to do in the procedure is to disable the mole's clock and enable clock 2's timer. By default, the timer on clock 2 is disabled. I've unchecked the timer enabled box, right? So 2 clocks, how fun. So go to clock, and actually I can just duplicate this block of code, and instead of clock 1, I can select clock 2. And what I want to do with clock 2 is I want to start it when I stop clock 1. And then in the timer, when the timer goes off, I want to do the reverse. I want to start clock 1 and stop clock 2. So in a way, the clock 2, it's shutting down its own timer, right? Instead of setting properties in the console, in Designer, I can also do it by code. And as we gain our skill, as we improve our skill with coding, it's a better way to do that. So what I'm going to do is go to clock 2, and just to make sure, I'm going to set its timer interval in the procedure. I'm not going to leave it to chance. And I'm going to set it to 3000. So that's 3 seconds. So what's going to happen, right? I'm turning off one clock to stop the mole, and I'm starting another clock, right? And that clock is going to wait 3 seconds, and then it's going to do whatever I tell it to do. What is it going to do? Once 3 seconds have run, it's going to restart clock 1. So the mole's going to start jumping around again, and it's going to turn itself off. To save us some time, I'm just duplicating code. And it should do it, right? So this is a very interesting technique when we use multiple clocks and a bunch of animated characters. Turn one clock off, turn another clock on, and then do the reverse. Okay, so that's how you create waiting periods in your app. And this is the right way to do it. The sleep function that we wrote, you want to avoid using this kind of a procedure. And this really is not the right way to inject a waiting period into our programs in App Inventor. When you look at JavaScript or Python or other programming languages, they have a built-in sleep procedure. So you always have the luxury of a built-in procedure that you can just use out of the box. Here we have to code it. And I'm showing you both the ways to code that and also what is the wrong way and the right way. So the right way is to really use a clock and a timer. Okay. All right, so this should do it. And one more thing I'm going to do is now I no longer want this sleep procedure. So I'm going to right click on it and disable the block. I'm not deleting things. So when you're playing around with this code, you can enable disable procedures and you can test it out for yourself. And the freshly minted sleep procedure that we called sleep 4, I'm going to add it to the callback of the mole sprite touched. And also set that parameter to 3000, which is 3 seconds or 3000 milliseconds. Okay. Clock 1 off, clock 2 on, clock 1 on, clock 2 off. That should do it. Okay. And now I click on the mole and 3, 2, 1, 0. Okay, excellent. 3, 2, 1, 0. Okay, there it is. But I can still, when I click on the mole once and it pauses, I can still click and you see the score going up, right? So I can still cheat. Yeah. So yes, the way we can stop that is actually by not just turning the clock off, but by also disabling the sprite. So let's go to sprite and grab the enable disable set method. Here we go. Set mole sprite enabled to false. Okay. And I need to remember to set it to true at the end of the waiting period before we disable the second clock, right? So yeah. So this little change means that when we are in that state of suspended animation, I cannot keep touching the mole to increase my score. Everything just actually stops. And again, it's speeded up. So I'm going to refresh the screen. That was a good suggestion to speed it up as we score points. It does make it challenging. Okay, there we go. Okay, and now I click on it, nothing happens until the waiting period is over. Okay, so we've fixed that. The only thing remaining to do is now implement the reset button, which is just lying idle. And all that the reset button will do is reset our score to 0. And given that we had this idea of speeding up the mole, we'll also need to, in our reset button, we'll need to reset the mole speed to the original. So that is now what we are going to do before we wrap up. Let's go to the button. There's only one button in this entire app. Let's pick our friend, the button click event. And all that we're going to do is set the score to 0. So I'm just going to steal code from here, duplicate it. And I do not need any of the math there. I just want to set the score to 0. Okay. I'm going to get rid of that math. And I also need to show it, right? So again, I will steal code from here. Please stop me if I'm going too fast. All I'm doing is copying and pasting code from the callback of the touched event to the callback of the to the click event of the button. Okay. So reset the score, show the new score. Now, if I click, yeah, that does that. I click on the reset button, score is 0. And let's remember to do that final bit about setting the mole's speed to normal. And again, I go to the clock The mole speed is governed by the clock's timer. I'm going to set the timer interval to whatever it was before, which I think was 1000, right? 1 second, 1000 milliseconds. And, let's also change the name of the button to reset button. Now notice if I change the name of components on the fly, I do not have to go back and rewrite all my code. It will automatically make those changes for me. So when I change the name of button from button 1 to reset button, you go to the code blocks and you see the event handler also has now reset button, right? So I didn't have to go to all those places and make those changes. It's a good idea to give components descriptive names. So I'm going to call this reset or score label. It's showing the score, right? So score label. So we can keep track of components in the coding canvas. As you can see, it gets really busy even for a relatively beginner application like this one, right? Okay, and yes, the name of the label changed to score label. These are just cosmetic changes that I made. And now let's see that the reset button does its job. We keep clicking on the mole. We could also make the mole disappear when it's clicked and appear from a new random location. So that could be your homework for how you do that. Just going to click it a few more times. Okay, I think that's enough, right? And now I reset it and the score is back to 0 and the mole speed is back to normal. That completes building the app. Okay, how are we doing on time? Oh, we are a little over. Okay. Hope all of you are still there. And yes, I think some of you are still there. Okay. So that's pretty much what I had planned for today. Any questions? Yeah, so we've covered some very key concepts here. Okay. So use the starter app. It's posted here. Download it to your local computer. When downloading, so if I click on this, right, it shows me like 3 files. Don't worry about it. Just go ahead and download it. It's actually just one file. Save it on your computer and then go to App Inventor, go to projects, import from my computer. You need to use this import project AIA from my computer and then choose that file wherever you stored it on your machine and pick it from there. So what you should have is for the mole mesh starter is a blank coding canvas. Close this pop-up. Okay, close this, cancel. Okay, cancel. You'll have a blank canvas. If there is anything on your canvas, just delete it. You will have the media files that you need to get started. I don't want you to waste any time hunting these audio files and images down. If you find better wallpaper, a better image for a mole, you have ideas like increasing the speed of the mole during the game. We already did that today, thanks to your suggestion. Whatever ideas you have, feel free to just implement them, right? Go for it, right? So, and if you get stuck somewhere, we always have officers or post a message in the discussion board. The checklist will help you just follow through all the steps that we did today. You have the optional quiz, which I really encourage you to take it. Even if you don't submit the quiz, just going through the questions here will help clarify. I changed something. Okay, will help clarify the concepts and just make sure you have 100% understood it, right? And we'll do more quizzes to test ourselves also as we go. Okay, so the code is all posted here. I strongly recommend you download the starter and build up the app using the checklist, which is also posted here in classwork. This is checklist for animated game mole mesh. And when you're done, you can download molemesh.aia, which actually has all the code. it should be almost identical to what we did today, but a little different. Yeah. So then you can compare what you did with this one for reference, and see if you did anything differently, and what we can learn from that. Finally, to install the app on an Android phone, you basically just download the APK file, which is an installer. Once you've downloaded it on your phone, just double click on it or launch it, and it will install the app. And there's a nice little finishing touch you can put to an app you build, like you can give it a name. So what you do is you go to screen, and in screen, you can give your app a name. You can be more creative than calling it mole mash. You can also give it an icon, So somewhere here is an icon property. You can make the app appear any way you like on your phone using the icon property. Yeah, here it is. Yeah. So I just gave it a mole icon. Yeah, that may be boring. You can find more interesting graphics and jazz up your app with those. So you have everything that you need. And unless there are any questions, I'll stick around in case you have any questions. Otherwise, we are done for today.
That was a great session. Thank you very much, Sanjay.
Awesome. Thanks, Denise. We built our second app, so give yourself a pat on the back.
But I did not have the file. That was a little bit late today. So I'm going to download them right now, and I'm going to work through dinner doing my part.
Awesome. Wonderful. Yeah.
Okay,
As always,
thank you.
feel free to reach out if you get stuck somewhere.
Will do.
Yeah.
I actually probably have to go back to look at old record. I didn't follow completely, so
No problem.
but
No problem.
this is interesting.
Yeah. No worries. As you actually do it, you will find it easier to follow the concepts. Okay. So it's always with coding. The more hands-on you are, the easier it is to absorb the concepts.
Okay.
And yeah, if you want, so not many people show up during office hours. So one way is you can code together with someone, right? And we can do it online during the office hours on Friday.
Oh, you already said your office hours?
Yeah, every Friday at 4 o'clock, we have the Zoom call and we have office hours.
Oh, with Zoom?
The
Do
same
you have
link.
Zoom link for that?
Yeah,
Oh.
the same Zoom link. The one that you used to join today's class. Use the same
Okay.
Zoom link. Okay.
Oh, I see.
Yeah.
Okay.
Friday
Okay.
at 4 p.m. Central Time. I'll be there.
Okay. I just saw that you are also leading meditation for Art of Living.
Oh yeah. Is that something you're interested in?
Yeah, sure.
Oh, I'll be happy to share more with you.
Okay.
Yeah. Have you heard of the Art of Living?
Yes, I actually took some courses already.
Oh, wow.
Yeah.
Oh, that's awesome. And do you
Right. But I have been away for some times.
Okay.
And so I just come back and I will be taking a repeater course.
Wonderful.
Yeah, that will be,
Yeah.
I think on the 19, 20, 21, 19, 20, 21st of November.
Let me just stop recording, huh? One moment. So all this does not get recorded. I mean, not that there's any problem with it, but it's just.
Oh, sorry.
No, it's no problem. You're fine. You're good.
Look like we are recording the notes